Okay, now we can use these functions, these formulas for sums and differences of angles, actually to produce new identities. Sometimes these identities are referred to as co-functions because they're sort of two functions that are related to each other. Let's start off with the following. Let's see if we can figure out what cosine of x minus pi over 2 equals. Well, first of all, let's just make a guess looking at the graph. So when you think of the graph of cosine, it looks like this. Now, what does it mean to replace x by x minus pi over 2? Remember, add to x, go west. So since I'm subtracting, I should go east. So I should move this whole picture to the east by pi over 2. So what happens exactly? Well, you have to visualize this in your mind's eye. If I slide this over, I'd get something that looks like this. I get the sine function. So in fact, this should be the sine function. So let's see if that's really right. So let's see if we can confirm that hunch. Let's see if that's really okay. Well, what would I do? Well, let's just take a look at cosine of x minus 2 and use the difference formula for cosine to see what this would give me. Well, okay, now remember, cosine is evil. It's the bad seed. So it wants all the credit for itself. So it's going to be cosine of x multiplied by cosine of pi over 2. And then it's so evil that since you're subtracting here, it's going to add. And then it throws in all the sines. Since it has to be there anyway, I'll throw it in. All right, so sine x times sine pi over 2. Okay. All right, well, what is this? Well, we have cosine x times cosine pi over 2. But look what cosine of pi over 2 is. Cosine of pi over 2 is 0. So in fact, this term drops out. So I get a 0 plus. And what's sine of pi over 2? Well, remember that sine of pi over 2 is actually 1. So in fact, this is just 1. So I see 1 times sine of x. And so I see this equals sine of x. So now we actually proved, using the difference angle formula for cosine, that if you take cosine and shift it to the right pi over 2 radians, you actually get the sine function. Now you know it exactly. See, before it looked that way when you did all that shifting, but we weren't sure if the curves matched up just perfectly. But now for the first time we're sure everything matches up just perfectly because of this great formula we can use. Let's try another one. Let's verify what happens if we take sine x minus pi over 2. So what happens if we shift the sine function? This is going to be maybe slightly hard to visualize. I'm going to take the sine function and shift it over. So what would it look like? Well, then it would sort of start down here and go up and come down like this. You see, I'm just shifting this over, so it sort of has this wave that's been displaced a little bit. What function is that? Well, if you think about it, it's not cosine, but it's the negative of cosine, because cosine does this, and this function would sort of do the negative of it. So it would just be the flip of cosine. If I were to be able to flip this, whoop, I'd get that function. So it should be negative cosine. So let's see if we can verify that this is really negative cosine. Okay, so I'm looking at sine of a difference. So I use the difference formula for sine. Sine is a very happy and welcoming function. So we take sine of x and we multiply it by the cosine, pi over 2. Everyone gets top billing. Since I'm subtracting here, I'll subtract here to keep it fair. And then I'm going to have the cosine of pi over 2 times, oops, sorry, it's a typo, cosine of x, I reversed the roles, times sine of pi over 2. Let's see what we get here. So what is cosine of pi over 2? Well, cosine of pi over 2 is 0. So in fact, this term just drops out. And what is sine of pi over 2? Well, sine of pi over 2 is 1. So this term drops out, and this sine of pi over 2 becomes just 1, so I'm left with that negative sign, cosine x. And that verifies the formula that we thought. So that's pretty cool. You can verify these things using these sums and differences angle formulas. Let's try one last one. Let's verify that tangent x minus pi over 2 equals minus cotangent of x. So let's see what happens now. So I'm looking at tangent of x minus pi over 2. So what do you do there? Well, there I've got tangent x minus tangent pi over 2. And I divide that by 1, and then I switch the sign, plus tangent x times tangent pi over 2. So that's what that looks like. Now we have to figure out what tangent of pi over 2 is. So what's tangent of pi over 2? Well, let's graph this. Here's 2 pi. Here's pi over 2. So let's see. You know, I'm getting a little nervous here, I must confess. In fact, I'm getting really nervous here. I'm getting really nervous. I'm getting really nervous because it's not defined. So what in the heck are we thinking here? It's not defined. If you take this thing and you were to shift it over, I admit that you're getting the right thing, but how in the heck do you do this? Huh. Okay, let's cut this. Okay, wait, stop. Before we cut, I just want to show you how you can sort of get around this little problem, and that's why sort of I was stopping. See, the stopping thing is the following. You see, I can't evaluate tangent of pi over 2. It's undefined there. So that's sort of a problem. What do you do with that? Well, I'll show you how we get around with that a little bit, and this is sort of, I'd call this sort of dubious math, but it's okay. See, this is undefined, so how do you sort of manipulate that? Well, let me perform a little trick here, just to show you how we can really get this formula. Let's just multiply top and bottom by 1 over the tangent of pi over 2. So I multiply something that looks like something over itself. It sort of looks like 1. This is a little bit dubious because, of course, that's not even defined, so it's a little bit shaky here. But just play along. This is sort of just a shaky thing, so maybe I should be shaking. Okay. But when I do that, just watch formally what happens. When I distribute this, what do I see? I see tangent of x over tangent of pi over 2 minus, and then tangent pi over 2 divided by tangent pi over 2 is just 1. And then what do I have on the bottom? I have 1 times that, so that's 1 over tangent of pi over 2. And then I have plus, and then there's a cancellation here. I'm just left with tangent x. Okay, now that's the dubious part. Now, what is 1 over tangent? Well, 1 over tangent, remember, is the same thing as cotangent. So in fact, I could rewrite this as tangent x times cotangent of pi over 2, and then all minus 1, divided by, and the same thing here, cotangent pi over 2 plus tangent x. Okay, now if you allow me to do that, which was just sort of acting formally here, very formal, I should be wearing a tuxedo maybe, but I'm just sort of manipulating symbols, not thinking about if it's allowable or not. Well, now I'm in fine shape, because what do I know about the cotangent? The cotangent is 0 wherever I have an asymptote on the tangent. So in fact, now I see that at pi over 2, the cotangent is 0. So if cotangent is 0, look what happens. This term is 0, because there's a cotangent of pi over 2 factor here. So this drops out. And this is 0. And so what am I left with? I'm left with minus 1 over just tangent x. So I see that this thing equals minus 1 over tangent x. And tangent x, 1 over tangent x, is the same thing as cotangent x. And so I actually did, in fact, prove this identity after all. But I had to do a little bit of trickery that, I don't know. But anyway, you can sort of see it formally. And in fact, you can make all that mathematics really okay and justified if you're just a little bit more careful. But why bother? You can sort of see, at least formally, this formula holds. And in fact, graphically, if you look at the graphs of these things and shift, you'll see the exact formula holds. So graphically, we can verify what we can prove here algebraically, but it's a little bit shaky. Anyway, now you can see that these are all cofunctions. This is the cofunction of that because they just shift of each other once you shift a little bit. Anyway, okay, enjoy these, and I hope you're not going to be too shaky yourself. See you soon.